Hi, I would like to talk about the first chapter of physics. It's related to kinematics, and specifically it is called describing motion. And at first, I want to focus on this topic called rectilinear motion. Okay, what is rectilinear motion? In order to talk about this topic, I need a definition related to particle. What is particle? Actually, in physics, we need particle definition frequently. That's a kind of tiny object. In other words, there is an object which doesn't have size or dimension, or it has, of course, it has size and it has dimensions, but we can ignore these dimensions because we don't need these dimensions for analysis. At that moment, imagine we have a tiny object here. It is called particle, and it has many applications in physics. Imagine there is a particle here, and it has motion, and imagine it's to the right. If the trajectory of this moving particle, look at the figure, please. If this trajectory is a straight line in the space, at that moment, it is called the rectilinear motion. Like what? Like moving car on a flat surface. Imagine you have a car, you have a moving car, and it's going on a flat road for 20 minutes. At that moment, you have rectilinear motion. Or maybe you have an airplane and it's moving to the north, for example, for 2 hours on a straight line. Therefore, it is rectilinear motion. In order to describe this kind of motion, we need two quantities here. The first one is displacement, and the unit of displacement is meters. Therefore, in order to measure the displacement, I need meter stick. The second quantity, it is time. And in order to measure time, I need timer. And the unit of time is second. So imagine here, I have this particle at the beginning. The initial position is here. I mean, this black color. So obviously, I want to put the origin here. Imagine I want to put this origin at the beginning or start point, and I need a letter like X, and X, it means the displacement of the particle. At the beginning, X is 0. But if you have motion to the right, of course, you have different values depending upon the time value. So you can measure this displacement, which is X. Therefore, at the beginning, X is 0. And of course, time value at the beginning, it is 0. Therefore, X is 0 here, and T is 0 here. In other words, the displacement is 0, and time is 0 at the beginning or initial position. Right now, let the particle go. Therefore, it will go to the right along this straight line. Therefore, imagine next time your position is here. Okay, if you want to continue, imagine your position is here. Similarly, you can continue like that. So you have different positions and different time values. Okay, imagine I want to focus on this. Therefore, from the beginning, to this point, for example, this one. Imagine you have this displacement because it's going to the right. And you can measure the time value for this displacement. Consequently, you have X value. You can measure X and you can measure time, both of them, both quantities. In other words, pay attention, everything should be compared with respect to origin, which is, sorry. Sorry, which is here. This is the origin. Okay. Or maybe you want to focus on this point here. Therefore, your displacement is here from the origin to your this position. This is your destination right now. This is your X. You can measure it by meter stick and you can measure the time by timer. Therefore, this is the corresponding time for this displacement. Or for example, you want to focus on third location from the origin from here to here. You can measure this displacement and you can measure the time of this displacement. Consequently, you can measure every displacement with respect to your origin. And of course, you should measure two quantities, X quantity or displacement and time quantity or T. Now I want to define something new, which is average velocity. Average velocity is, it has a definition here. The displacement traveled by particle per unit per total time of traveling. Therefore, you have total displacement over total time of traveling. It is called average velocity. So if I want to use the letters, I can do it like this. Instead of average velocity, I have this letter, V bar. V bar means average velocity. Displacement traveled by the particle, it is X, which is here for your measurements. X and the time is T. Therefore, this is your equation. Or this is the definition of average velocity. According to this formula, X is displacement traveled by the particle with respect to the origin. And it has a unit. It is meters. This is the unit of X, or this is the unit of displacement. Okay, the unit of time, it is in seconds. And velocity or average velocity has unit. It is meter per second. In general, we have a system of units in physics. It is called, that's a standard system of units, or SI. There are three major quantities in physics, like mass, length, and time. In SI system, unit of mass is in kilograms. Unit of length, it is in meters. And unit of time, it is in seconds. I'm using SI unit here because it is frequently used and it's very popular. Okay. Therefore, V bar, or average velocity, follows this equation. In other words, in order to talk about the whole motion, in order to justify the whole motion of your moving particle, you should focus on the whole motion and you should focus on the total time of traveling and follow this equation. At that one, you can reach this value or average velocity. Average velocity should be used for the whole motion. We don't care what's happening in each time interval. We don't care. And it doesn't matter because we should focus on the whole motion from the first position or initial position to the last position. Therefore, we can follow this equation to find V bar. Okay, let me give you some examples regarding average velocity. Example. Imagine there is a particle which has rectilinear motion. It is going to the right, like this. Why this observation? We can see that this particle travels from here to here, from the first position to last position. It travels 120 meters in 10 seconds. In other words, in 10 seconds, it should travel 120 meters. What is the average velocity for this whole motion? Or what is V bar? In other words, x is 120 meters. This is total displacement of your particle. And total time of traveling, it is 10 seconds. Find V bar or average velocity. Okay, we have a formula. V bar is x over t. Follow this equation. V bar equal to x divided by t. Total displacement, it is 120. Total time, it is 10. Therefore, V bar is 12 meters per second. Answer of this problem. Okay. I want to emphasize it. This value, 12 meters per second, it is used for only whole motion. Maybe it's not valid for each second, this value. And we don't care the time interval. We should focus on the whole movement of the particle here. Next example. We have a moving particle, and the V bar or average velocity of this particle is 50 meters per second. What is the required time to travel 800 meters? What is x? 800 meters. If we want to travel 800 meters with this velocity, with this average velocity, what is the time value or what is the required time for this traveling? So follow the basic equation here. So V bar equal to total displacement x over total time. V bar, it is 50 equal to 800 divided by t. Therefore, t equal to 800 over 50. That's 16 seconds. Answer of the question. In other words, by this velocity, average velocity, 50 meters per second, the total displacement which is 800 meters, can be traveled in 16 seconds. So total displacement and total time. Okay, maybe for example, in first time interval, for example, between 0 second to 1 second. So imagine, remember this one, the total time of traveling is 16 seconds. But imagine between 0 and 1 second, maybe you have different velocity here. Maybe velocity between 1 second and 2 seconds, maybe you have different velocity value here. But we don't care. We should focus on the whole displacement, and we should focus on the total time of this motion. That's important here. But of course, this value is not precise quantity, because it's not, maybe this number is not valid for each second. I mean, for example, 50 meter per second is not valid. Maybe it's not valid for each second. It is valid for the whole motion. In other words, average velocity is a kind of approximation. And of course, maybe it's not real velocity necessarily. Okay, next example. There is a particle here. It has 3 steps. In first step, which is, for example, step number 1, from 0 second to 10 seconds. For example, here, t equal to 0 here. And of course, displacement is 0 here. X is 0. It is a start point. Okay. After 10 seconds, of course, here, time is 10 seconds. And displacement here, from here to here, the first position to this position, it is, imagine, 20 meters. The next step here, between 10 seconds to 20 seconds, just here. Imagine it is 10 seconds to 20 seconds. This displacement between 10 and 20, it is 70 meters. And the next one, the third step, between 20 and 30 seconds, equal to 30 seconds here, and displacement is 5 meters here, only for this time interval, only for this step. Between 20 and 30 seconds, it travels 5 meters. What is the total displacement? What is the average velocity for the whole motion? What is v bar? Okay, so according to this definition, I told you, you don't care about each time interval, about each second. We don't care. We should focus on the whole displacement and total time. Okay, follow this equation here. V bar equal to total displacement x over total time. What is total displacement between 0 and 30 seconds from the beginning to the last position? Okay, according to this figure, you can calculate the total displacement. Total displacement is summation of these values. Let's do it. It is 20 plus 70 plus 5. And what is total time of traveling? Of course, 30 seconds. It takes 30 seconds, the whole motion, yeah? Therefore, it is 30 in the denominator. Therefore, it is 95 over 30. Therefore, V bar is 3.17 meter per second. This is average velocity for your particle. This is the answer of this question. Okay, in other words, average velocity for the whole motion is 3.17 meter per second, which is approximation. Of course, it is not real velocity for each second. Maybe you have different velocity for each second, but in general form, you have an average number here for the velocity, that's 3.17, and it is used frequently for having estimation. Consequently, it's very important, and it's very necessary in order to talk about the motion and describing motion. Of course, it's so important. Okay. Let me give you this example here. Look at this figure. For example, this is your particle for first step. For example, first time interval, 0 seconds. Of course, t equal to 0 second at the beginning and x equal to 0. T equal to 1 second. X is, for example, 2 meters. It means it travels 2 meters in 1 second. For second time interval, imagine here. Between t equal to 1 to t equal to 2 seconds. For only this time interval, it is 3 meters. Okay, what is the velocity, average velocity for the whole motion? Of course, V bar is 2 plus 3 total displacement over total time. Of course, it is 2 seconds, this one. It is 5 over 2, that's 2.5 meter per second. See, if I want to calculate the velocity for this time interval, the first time interval, you have a different number. If you want to calculate the velocity for second time interval here, this one, again, you have different velocity value. It is different from V bar. But V bar is valid for the whole motion of your moving particle from 0 to 2 seconds. Therefore, for average velocity quantity, you don't care about the real velocity for each second. We should discuss this quantity for total displacement and total time. Thank you.